Hi, in this video we're going to be looking at the equations of circles and hyperbolas and just some transformations of those and how we can move those around. So first of all, starting off with circles, this little video kind of describes what's going on here. We can think of a circle as just the set of points the same distance from one point. So in this one here the circle is 10 units away from that center point there. So we can use the distance formula to think of this. If every point on that blue circle is 10 points away, or you could think of Pythagoras' theorem as well, the distance from the center to that point P, xy, is just x squared plus y squared equals 10 squared. Or you could use the distance formula. The distance is 10, x and y, the distance from 0 and 0, so we get the square root of x squared plus y squared equals 10. Square both sides, we get x squared plus y squared equals 100. And that's the equation of that circle. In general, we can say any circle is just x squared plus y squared equals r squared. Just using this simple diagram here, showing that every point on the circle satisfies that particular equation. So here's a circle, x squared plus y squared equals 1 squared, x squared plus y squared equals 2 squared, and so on and so on. So if I change the value of r, you can see that the circle just gets bigger. Okay. So the thing to remember here is that it's x squared plus y squared equals r squared. So that number there on the right is the radius squared, not just the radius. All right, let's have a look now at equations of circles with a little bit of transformations in there. So equations of circles where the center is not at the origin. So we know this equation here is x squared plus y squared equals 3 squared, or x squared plus y squared equals 9. Let's take a look at a different form, and that is this one here. So looking at the equation x minus a squared plus y minus b squared equals r squared. This is a circle where the center is a, b. So it's a transformation again. So the x minus a, think what's the value of x that makes that 0? In this case, when a is 1, it's 1, which means that the center of the circle has been shifted across 1. If I just press play there, you can see changing the value of a moves the circle horizontally across. So this would be x plus 5 squared over here. Okay, so we've moved it 5 to the left-hand side. And same thing for the value of b in here. The value of b just shifts the center of the circle vertically up and down. Okay, that's what those two numbers there do. So here's x plus 5 squared plus y minus 1 squared. So the center is at negative 5, 1, and the radius here is 3. Last kind of graph we're going to look at here is what's called rectangular hyperboles. And these are graphs that look like this. And the equation is y equals, in this case, 1 over x. If I change the value on the top line there, there's y equals 2 over x. If I keep changing the value, the hyperbola just gets further and further away from the axes. Now let's just examine this. If I look at y equals 4x. Another way you could write that is x times y equals 4. So this is x, y equals 4. So we're thinking all the possible values of x and y where when you multiply them together you get 4. So obviously 2 2's on this graph, 4 1 will be on this graph, 1 4 will be on the graph. That's how we get all the points. Every point on this line satisfies the condition that you multiply them together you get 4. So you get 2 branches here. If I zoom out, you can see that the x and the y-axis are asymptotes, meaning that the curve gets closer and closer to them but does not touch. Okay? So that is a rectangular hyperbola, y equals something over x. If the value on the top line, the number on the top line is negative, the hyperbola is now in the different places. It used to be here and here, now it's over here and here in the other quadrants of the Cartesian plane. So this would be y equals negative 3 over x. So every point on this curve satisfies that when you multiply them together, you get negative 3. Okay, so 3, negative 1 will be on this curve. So that's how you can tell if you're given a question where they give you the graph, They say, what's the equation? They give you a point on the graph. That's the way to tell. You know, y is equal to something over x, or x times y equals something in the most basic cases. Let's take a look now at the final transformation where we have y equals k over x minus a plus b. So the transformation's here. The x minus a does the same thing as it's done all other graphs. This moves the graph left and right, so it's a horizontal translation. So if I change the value of a, you can see that the graph just moves left and right. So here is y equals 2 over x minus 2. So the 2 stretches the graph out away from the axes. The x minus 2 on the bottom moves the graph 2 to the right. So now the asymptotes are no longer the y-axis, but it's the line x equals 2. That's the asymptote for this graph here. Again, if they give you a point on the curve, if you know the basic formulation of what this equation looks like, you can substitute in a point to find your values of a and k if you've got a few points on the curve. So they might give you that you've got 4, 0, 0 on the curve, and we might also tell you that 4, 2 is on the curve. Okay, and you can probably guess as well what b does. B just moves the graph up and down vertically. Okay, so there we go, I'll zoom out a little bit. So the value of b is just moving the graph up and down. So if you have, in the case that I had, b equals, let's say 3, you can see that no longer is the x-axis an asymptote. The line y equals 3 is an asymptote. So this equation that we're looking at now is y equals 2 over x minus 2 plus 3. So it's out a bit than the normal one. It's shifted across and it's shifted up.